Hello friends, I welcome you in lecture number 2 on singularities and zeros. So in previous lecture we have discussed what is meaning of singularity and isolated singularity. In this lecture we will define different types of isolated singularities. So before that we just recall what is isolated singularity of a function f of z. So suppose we are given some function f of z and suppose z0 is singularity of this function f of z. Then if there exists a deleted neighborhood of this point z0, say 0 less than absolute value of z minus z0 less than r, in which this function f of z is analytic, then z0 is called an isolated singularity of this function f of z. So f of z has an isolated singularity at point z equal to z0 if there exists a deleted neighborhood of this point z0 throughout which our function is analytic. So now with this definition in mind, we discuss classification of isolated singularities. Now as we know that if our function is analytic in an annular domain centered at z0, then our function f of z can be represented by Laurent series in this annular domain. So if z0 is an isolated singularity of this function, by the definition of isolated singularity, our function is analytic in this domain. So f of z can be represented by Laurent series in this domain. So suppose f of z is having Laurent series expansion in this deleted neighborhood. So we will have this type of Laurent series expansion in the deleted neighborhood of isolated singularity. Now depending on the Laurent series representation, we can define different isolated singularities. Now isolated singularities depend on this part of Laurent series which contains negative powers of z minus z0. This we can rewrite as sigma z minus z0 raised to minus n equal to 1 to infinity. So this part of Laurent series of this function f of z which involves negative powers of z minus z0 is known as principal part of function f at point z0. So depending on the behavior of this principal part, our point z0 will be characterized by different types of isolated singularities. So now if our function is analytic in this deleted neighborhood of z0, function has Laurent series expansion in this deleted neighborhood. So whenever we have Laurent series expansion, we may have negative powers of z minus z0. So depending on different functions, this principal part may be different for Laurent series of different functions. For some functions, this principal part may have finite number of terms. For some functions, this principal part may have infinite number of terms, or for some functions principal part contains no terms. So depending on the number of terms in the principal part, we have different types of isolated singularities. So if this principal part contains finite number of terms, then this point z0 is known as pole of order whatever is finite number there. Suppose there are two finite number of terms, then it is known as pole of order 2. So if number of terms in the principal part of function f of z has finite number of terms, then z0 is called a pole. If this principal part has infinite number of terms, then z0 is known as essential singularity, and if this principal part has no terms, then z0 is called removable singularity of function f of z. So we again discuss all these things. We have written here systematically. Classification of isolated singularities. If z0 is an isolated singularity of f of z, then there exists a deleted neighborhood of z0, say 0 less than absolute value of z minus z0 less than r, in which function is analytic. Now, as we know, if function is analytic in an annular domain, then function can be represented by Lorentz series in this annular domain. So, because f of z is analytic in this deleted neighborhood, suppose f of z can be represented by this Lorentz series sigma an z minus z0 raised to n is from 0 to infinity, and sigma n equal to 1 to infinity bn divided by z minus z0 raised to n. We can rewrite this as, if we put n equal to 1, we have b1 over z minus z0 plus b2 over z minus z0 square and so on. Suppose nth term is bn over z minus z0 raised to n and so on, and this Lorentz series expansion is valid in this deleted neighborhood of z0. Now this portion, as we discuss, this portion contains negative powers of z minus z0, and it is known as principal part of our function at z0. So here we have written the portion of this series on right hand side of 1. Okay, this portion of this series number 1 involving negative powers of z minus z0 is called principal part of function f at point z0. So this portion is nothing but principal part of given function f at point z0, which is isolated singularity of given function. So whenever our function has isolated singularity at some point z0, then we will have this type of principal part in the Lorentz series expansion of given function f. So depending on the nature of this principal part, this z0 is classified. So suppose this principal part has finite number of terms. If the principal part of a function f of z at z equal to 0, z0 has only a finite number of terms, suppose finite number of terms are m, then z0 is called a pole of order m of given function f of z. Now suppose there is only one finite term, suppose there is only one term in the principal part, then in that case z0 is called a simple pole. So if z0 is a pole of order m, then principal part will have m non-zero terms b1 b2 up to bm. So if z0 is a pole of order m, then Lorentz series expansion will look like this. Here number of non-zero terms are small m in number. So principal part contains m non-zero terms. So if principal part contains m non-zero terms, then z0 is called pole of order m, or equivalently, if z0 is a pole of order m, then principal part will contain m non-zero terms. So we have last term as bm divided by z minus z0 raised to m, where m is non-zero. Now another definition is isolated essential singularity. So if the principal part of a function f of z at z0 has infinite number of terms, then z0 is called an isolated essential singularity of f of z. And if the principal part of a function f of z at z0 has no terms, if there is no term in the principal part, that means there is no negative power of z minus z0, then in that case z0 is called a removable singularity of f of z. So depending on the principal part, we have classified isolated singularity of f of z into three categories. Isolated singularity may be pole, or it may be essential singularity, or it may be removable singularity. So if there is no term in the principal part, if the principal part of a function f of z has no term, then z0 is called removable singularity. If the principal part of f of z at z0 has infinite number of terms, then z0 is called an essential singularity. And if the principal part of f of z at z0 has finite number of terms, say m, then z0 is called a pole of order m of a given function f of z.